Okay. Is that going to ever turn on? It's just slow. All right. So we are skipping chapter 19 and we're going to chapter 20. However, having said that, chapter 19 is a review, and it's a very good review. So if you guys would like to practice that, it's about time to have another test, isn't it?
No, we just took one. Oh my God. That was last week, please.
Okay, well, let me just say this. So kind of my tentative plan today is the day before Halloween. That was why I scared you.
Oh my gosh. Unless we want to do like a test just on this.
But I'm going to keep it here. We're going to cover chapter 20, which is the t distribution today. We're going to cover the next one, which I can't remember what chapter it is, but it's going to be on the chi-square distribution, and it's going to be a test of independence. Then we're going to have a review, then we'll probably have a test. So yeah, we probably are. Because would you like me to cram more information on the test, or would you like to keep it small?
Is this our last test then, and then our project?
And then we're going to work on our project. Now, having said that, let me ask you a question. One of the things that I would like to do for the project, I don't know if we can do it, the election's on November 6th. Would you guys, I think it would be really interesting and it would be really cool, because if you guys could collect data this week, then you could compare it with the real election and see how good your polling was.
Like, you want us to ask people stuff?
Yeah, I want you to ask. Honestly, here's what I would like to do. I would like you to find out. I'm not sure if this is true, but I think it's true. The Congressional District 4 is like Lehigh and west of I-15. And Congressional District 3 is like American Fork and east. Okay? So ideally, it would be nice, especially in District 4, which is Mia Love and Ben McAdams. That's actually going to be a close election. Okay? So what I'd like you to do, and I can't remember who is even running in 3. I know John Curtis was going to run, and he's probably going to win because he's a Republican, and that's what Utahns do. But if people live in District 3, I'd like you to say, are you going to vote for John Curtis, or who's he running against? Does anybody even know?
I don't live in this county.
Yeah.
I voted, but it was where I live.
In California or something? Where
St.
you
George.
live? St. George.
Washington.
Oh, Washington. So are you in John Curtis's district, or are you in Mia Love's district?
Huh?
Did you vote for John Curtis or Mia Love? Or Ben McAdams?
I can't remember. I think I just did the one that was already in it.
So would you guys like to do that? Because you're gonna have to do it like this week.
Can we just do like a poll on Facebook? Like, ask your friends?
I don't have any Facebook.
Yeah.
I would really like to do this. The problem is, I need to teach you guys a lot more stuff in 6 days.
Do a survey.
It would be fun because it would be real data and you could actually do it. But normally I do this at the beginning of the semester, but I did a little differently this semester.
Oh, but this is a group project, right?
It is a group project.
John Curtis is running against Kathy Allen.
Kathy Allen.
That was 2017.
That was in 2017. I'm sure he has an opponent, but anyway, I don't know who it is. I'm in Mia Love's district. That's all I know.
Chris Herod?
Chris Herod? No, that sounds like the primary.
Where do you live?
I live in Lehigh.
Oh.
That's why I know. My in-laws live in American Fork, and they're voting for somebody else. So, anyway, all right, let's get moving on. I don't know. Normally I make a lot of rules about how to collect data. I don't think we could do it in a week. So, we'll save it. It would have been fun. But we'll save it for another day. All right. So, chapter 20, we're going to continue. Why is it? There we go. I was off the air. All right, so we're going to do chapter 20, which is hypothesis testing for a mean. Okay, now we've already done that. We did that in chapter 17 and 18, right? Okay. Today we're going to introduce to you a new distribution, which is called the t distribution. Okay. So, The question, well, I kind of want to just do an example.
How is it that you know?
Actually, let me just, I'm going to say, here's the key question. Do I know the population standard deviation? Okay. Did you have a question? Ms. Dela?
Yeah. So like, how do we know if we're gonna do the Z or the T?
That's what I was just answering.
Oh,
Okay? Okay? How do you know if you're going to do the Z or the T? Do I know the population standard deviation? What are the only two possible answers? Yes or no, right? Okay? If the answer is yes, it is a Z distribution. If the answer is no, it is a T distribution. Okay? Now, the formulas are very, very similar. The Z distribution formula, as theoretically you should already know, x bar minus mu over sigma over the square of that. If the answer is no, it's a T distribution. The formula is x bar minus mu over S over the square root of n. What's the only difference in those?
S.
The S and the sigma, okay? If you know the standard deviation, population standard deviation, you're going to use sigma. If you don't, you're going to use S, okay? Now, let's talk a little bit about the student T distribution. It was discovered by a guy named William Gossett. Okay, he wrote under a pseudonym called Student T. That's how it got its name, the Student T distribution. By the way, just FYI, he worked for a brewery. So if you thought there was nothing good about alcohol, well, you have the T distribution. Okay? You all will have a drink after class. Okay? All right. Anyway, so it's similar. Okay. It's similar to the Z distribution, but with fatter tails. Okay? So if this is the Z distribution, okay, let's call that the Z distribution, then your T distribution, I'm going to pick a different color, like red, is going to be very similar, but it's going to be fatter tails. Okay, it looks a lot like a bell curve, only it's going to have fatter tails. Okay, so both of them are centered about 0, but you can't use the 68, 95, 99 rule on the T distribution because it's different distribution. It doesn't work that way. Now, one of the other differences about the T distribution is it has something called degrees of freedom equals n minus 1. Okay? So, another thing that's different about the T distribution is the shape changes based on your degrees of freedom. Okay, df for degrees of freedom. As n gets large, it approaches the normal distribution. Okay. Couple things in the book that I do want to mention. I didn't have on my notes. Let me just pull that up here really quick. It's funny because we're only going to cover probably the first 4 sections, but this is from after that, which is kind of useful information that they should have included sooner. Let me find it here just one second. It says here, if your n is less than 15, and roughly normal, use T. I'm going to call that A. Okay?
Roughly normal.
Roughly normal. Or maybe I shouldn't say roughly normal. It says that in the book, roughly bell-shaped. B, if it's skewed, do not use T if n is less than 15. If n is greater than 15, use T if no strong skew or outliers. Okay, outliers always mess things up. Okay? And the if I mean 15 is kind of a cutoff. Or whatever. I'm not too concerned. If n is greater than 40, can be used even if it's skewed. Okay? And like I said earlier, if n gets really big, like 100, it's going to be very close to the normal distribution. Okay? It used to be in this class we wouldn't teach you the t distribution. I'm excited we're teaching it to you now. Okay? Now, there is a t distribution table in the book. It's not as good as the one that I'm giving you. You can use it, and I don't have it on a PDF or anything, so we'll use mine. But hopefully they'll be close enough that they'll be the same. Okay. All right. So here's an example that I'd like to do. So let's share my screen here. Okay, so here's what we're going to do. We're going to just do an example just like we normally would. And we're going to treat this as if you don't know which distribution to use, because hopefully you don't. Or hopefully you'll be able to figure it out though. Okay? All right, so here we go. The Centers for Disease Control, CDC, says the mean cigarettes smoked per day by smokers is 18.1. We obtain a simple random sample of 40 retired smokers to see if they smoke less. A sample results in a mean of 16.8 cigarettes a day and standard deviation of 4.7 cigarettes. Use alpha equal 0.10 to find out if retired smokers smoke less. Okay? Yeah, I guess the idea is they're not working, they're retired, so they don't got any stress, so they don't need to smoke, right? Okay? All right, so what is step number one? Find the numbers. Okay. Brock, can I pick on you since I already picked on Kristen? CDC says mean cigarettes smoked per day by smokers is 18.1. What is 18.1? Is that mu? Are you sure? That was like a Jeopardy answer, right? Yeah, that's correct. Okay. We obtain a simple random sample of 40 retired smokers. What's 40? What'd you say? N. Speak with conviction. Okay. Sample results in a mean of 16.8 cigarettes per day. What's 16.8? X bar. Are you feeling more comfortable picking these out now? Good. Standard deviation of 4.7 cigarettes. What's 4.7? We've got a difference of opinion. Sigma or S? It's from the sample, so it is S. Are you sure? Okay, good. Okay. Alpha is 0.10.
So the sample mean is X bar and the population mean is mu?
Yeah, that's correct. The sample mean is X bar. The population mean is mu. Are you clear on how to tell the difference? Okay. All right. So step number 2 is categorical or quantitative. Survey says, Robert? Quantitative, are you sure?
Yes.
Okay, good. That was conviction.
What is it categorical?
When is it categorical?
We never really have.
Yeah, we've done them,
When
remember?
it's proportions.
That was our first quiz.
Right.
When it's a proportion. If it's a proportion, it's going to be categorical.
Okay.
Okay? All right, step number 3 is what? What is it, Keith?
Find the null and alternative.
Null, the alternative, the null hypothesis, and the alternative hypothesis are
U equals 16.8.
16.8. She's shaking her head. I thought you said mu was 18.1. Didn't you say that? Okay, sit closer. Lots of empty seats in here. All right, the alternative is mu what?
Less.
Less than or greater than?
18.1.
Less than 18.1. Why is it less than?
Yes, I need to read it.
Because you guessed.
16.8 is smaller than 18.
Well, 16.8
Okay.
is smaller than 18.1, but you're not
We're
supposed to
trying
look
to
at the
say
data.
if it's smaller.
We want to see if
See if they smoke
It's less.
retired smokers smoke less. That's why it's less than. Okay?
Even if that's greater.
Now, even if it's greater, what if it came at the V20? You could still see if they smoke less, but you'd be like, ain't no way I'm going to say they smoke less, right? They smoke 20. They must be stressed out because they don't have a job. Okay? All right. Question number 4 is, hey, before you go, Kristen, let me just ask you this question. Which type of a test? A Z, a T, a chi-square, or an F? Oh, sorry, you don't do those. You only do the chi-square. That was my other class. You said it's a T because that's what we're learning today? Okay, that's correct. But how do you know when we're not learning it? How will you know on the test? Yes, it's a T because we don't know the population standard deviation. Now you can go. Okay? Thanks. Watch the video. Okay? All right. Do you understand why it's a T?
So, and then what's the name of the T? The one sample?
So it's a one sample T test. Or you could put T mean, because we're testing the mean as rather than a portion. Okay? Now, quick question. Do I know the population standard deviation on a proportion test? No, I don't. But it's still a z because I can figure it out, right? Do you remember how to figure out the population standard deviation on a proportion test? And you've all got your formula sheets still. Did she take her formula sheet?
I got it.
Oh, she gave it to you, thank you. P-hat is the sample proportion, not the population proportion.
What was the question?
The standard deviation on a one sample proportion test.
You just type in equals standard.
Nope, you actually do not do that.
Oh.
Is it the xi minus mu?
Nope.
X minus mu over c.
Okay, let's do a quick review here. What are the four equations? Well, I think maybe you only know three. What are the three equations that you should know for the test? Two of them I have written on the board.
So it's the t-score and the z-score.
The t-score, so this is one. This is the second one. What's the third one that you should know already?
Population standard.
It's a z,
P
p-hat minus p,
over square root of PQ.
square root of pq divided by n. What's the standard deviation of this? It's the denominator, it's the whole thing. Okay? That's the standard deviation. So those are the three equations. I'm going to teach you another one on Thursday. Okay?
So what's this one like?
That's one right now.
I was just reviewing that because some of you have already forgotten it.
Oh.
And I was asking what the standard deviation was, and the standard deviation is the denominator.
There's a lot of them. It's just kind of like
Yeah.
sometimes.
I know. Just so you know, you're going to learn the 4. My other class has to learn 14. Okay? We're already like halfway through. You guys are kind of halfway through too. More than half. All right, so let's go back. All right, so here we are. One sample mean is going to be t. T equals x bar minus mu over s over the square root of n. And I'll underline it so it looks like a fraction. And let's see who haven't I picked on. Gentry, I don't think I picked on you. Can you help me punch in this?
Yeah. Divided by the square root of 40.
Okay. So we're going to take that. We're going to take the numerator. We're going to divide it by the denominator. We're going to get negative 1.74. What is that value called, Robert?
Maybe your no, sorry, it's your
Z T score?
It's your t-score. Okay. Your voice went up, Robert. She sounded like a female. All right. Oh, this is because she answered. I was just kidding.
Oh, sorry.
Okay. She's like, he's making fun
I was
of
like,
me.
dang.
No, I was making fun of you. All right. 5 is find the Jordan p-value. Okay, now, there's 2 ways to do this. Okay? The computer way is actually going to be easier, but you're going to have to do it the paper way on the test. Okay? Let's do the computer way first. Okay? If you were going to come up with a t-score, p-value, what command would you think you would use? Norm S dist is not the correct answer because it's not a z-score. What would be your second guess?
Or T dist.
Norm T dist. Close to get rid of the norm. Because it's a t distribution. T dot dist. Okay? There you are. T dot dist. In fact, is that on your formula sheet? It is. Do you see that? It's right there. Bottom right.
Oh.
On the front page. Okay? You've got all the formulas right there that you're going to need. T dot dist. Now look here. I've got 3 choices to choose from. What do you think 2T stands for? Two-tailed. What do you think RT stands for? Right-tailed. What are we doing in this test? We're doing what kind of a test? Oh, we didn't draw our picture, did we? So we don't know that answer.
We're looking for.
We're looking for a left tail because we think they smoke less, right? Here, let's go back. We're going to draw our picture here. Okay. We forgot to draw our picture for our p-value, right? So we're going to draw a t-distribution, which is going to look a lot like a normal distribution, only a little fatter, right? Okay. What's the mean of the t-distribution? 0. What value did I get? -1 point. I thought it was a 3. Yeah, 1.75. You're right. -1.75. Do I want to shade the area to the left or to the right? I want to shade the left tail, okay? So going back to Excel, okay. Oh my gosh. Did it share? Share. I'm going to do t-dist, and if it doesn't say, it's a left tail test, okay? What do you think I put in for x? Our t-score. We should call that t, right? Come on, Bill. Okay, degrees of freedom. What's my degrees of freedom? N minus 1, and my n is 40, so I'm going to put 39 degrees of freedom, right? Do I want the cumulative? You're almost always going to answer yes on here, true. Okay, so just put true in there. Okay? So I got a p-value of 0.04405.
So we do the t-value, the degrees of freedom.
And then say true. Now on the right tail test, it doesn't ask for the true. You can ignore that. But anyway, now how do you do this on the table? Okay, I think my table is a nicer table than the one in the back of your book, but they work basically the same way. So I'm going to pull this up besides the fact that you can see this. Okay, here's your T table. Now look at this. Notice this it shades it to the right, not to the left. Notice also I've got my degrees of freedom column here, okay? I'm going to go down here to 39 degrees of freedom, so I'm on this row right there. I'm on that row, okay? Now the problem with this table, you're not going to get an exact value, okay? I got a value of 1.75, right? Yeah, here's my t-score, 1.75. So what you're going to do is you're going to look and say, now mine's negative, I'm going to ignore the negative. The reason I can do that is because it's symmetric, okay? Because it's symmetric, so 1.75, you can see that 1.75 fits in between those two numbers there, right? Do you see that? On 39 degrees of freedom, that means it's in between these two numbers here. So what I would say is my p-value is between 0.025 and 0.05. So with the table, I'm going to say 0.025 is less than the p-value, which is less than 0.05. That's the best you can do. You cannot get an exact value with the table like you can with the computer. Okay? All you can say is your p-value is in between 0.025. Now we're going to compare that value with our alpha, right? So step number 6 says compare, oh, it says reject or not. Reject or not. Okay. So, Gentry, you remember the phrase? The phrase that pays? Okay, is my p-value lower than my alpha?
Yes.
So the answer is reject. Okay? And finally, the conclusion is, okay, so we've rejected this, right? So, Tracy, conclusion.
This one is we do not have enough data to have evidence.
There is or is not?
There is.
Are you sure? There's not?
See, like, I don't know what entails enough data. If
Okay.
it's close to your alpha,
Okay, so you remember here,
you reject it.
if we do not reject, there is not enough evidence. If we do reject, there is evidence.
Because
So we rejected it, so there
there is enough.
is enough evidence that
That
retired smokers smoke less. Are you sure?
a little bit.
A little bit. You should have said, yes, I'm sure. I know what I'm talking about. Okay? Are you going to ace my test? Or are you going to ace the homework? Okay? All your homework that I'm going to do you want me to give you more than what's in the book?
We only do what you give us?
Give us what
Like
is
not
most
ignore the
likely
book part,
to
'cause then, like,
apply.
Because you're gonna write the quiz or the test.
Well, I want you to know the seven. Who's memorized the 7 steps? You're getting close, right? I mean, it's not that you have to memorize them, but you should do them so often that they should be memorized. Okay? So, yes, we're going to follow these same steps even on Thursday. Okay? So, all right. I will post this up. Now, by the way, we didn't record this, but this was the example we did at the beginning of class. Okay? This is a z-test because I know my sigma. This is a t-test because I don't know my sigma, I only know my s. Okay? I may give you both. If I give you both, which one should you pick? No, not either.
You give us both what?
Both s and sigma.
Sigma.
Oh.
Sigma.
Which distribution should you pick? There's no sigma distribution.
T.
If I give you both,
Oh wait, you pick T because you know this. No, you pick Z.
you pick the z because you know the population.
That's
Okay, he was right.
You said sigma, you didn't say z?
I said Z.
Okay, well, you gotta speak up. All right, okay, well, go Red Sox. It'll be a fun year next year, and now we're on to football season. Go Patriots.
There we go. Oh, you did not.
Okay.
They just beat the Bills last night.
I have a hard time when the Jazz play the Celtics because then I'm like, oh, I don't know who to root for.
You have a good taste in sports.
All right, see y'all tomorrow, or Thursday.
Thank you.
Oh, yeah, turn in your formula sheets.